Morning, guys. Are you good? Okay, this week we'll be writing on module 2.1, which is that if and else statement. The open book quiz is there, but module 2.1.2, you've already written about that. If you remember, statements and flow control. So you won't be tested on that because you've already written on that already. But we will also do 2.2, which is more types. Let me just show you. It is types and where we use them. First we are going to go through 2.1. Which is we look a bit deeper into if statements, and there's a lot of examples that we are going to go through, which I think explain a bit better. You all remember how an if statement work? Do you all remember? Yes, you do. So the first thing we do is we always use the keyword if. And then in the parentheses, that is where we put our test condition. And if our condition is true, then that's the statement we perform. Can you see they perform the condition if it's true? But if it false, we use the else statement. So in a computer, a true is represented by a 1. Remember we said computers work in ones and zeros. So a true is represented by a 1, and a false is represented by a 0. You can also see if the condition is true, its value is not equals to 0. The value that's not equals to 0, that is 1. Right? Then you perform the condition if it's true, which is that condition. And if the condition is false, which is equals to 0. Now, if it's false, then it's 0. Then perform the condition, the false condition. Do you all get that? Yes. So there's another example here. So what will happen if the weather is good? If you look at this example here. Go for a walk. What if it's not good? Go to a theater, watch a movie or something. But you see that last statement here, which is have lunch. That statement is outside of the if statement, so it doesn't depend on that condition, whether it's true or false. It will always be executed. So it doesn't matter if the weather is good or it's bad. You're always going to have lunch. So if you notice from the previous example here, we only had one statement inside the body of the if. That's how we didn't use a block. But now if we have more than one statements, you see here we have that 1 and 2, and we've put it inside a block. to remember what a block is inside the closing and opening and closing curly braces. So in this case now, if the weather is good, you'll go for a walk and have fun. But if that is not true, if the weather is not good, you'll go to the theater, enjoy the movie. But you always have lunch. So that last statement, which is outside of the if statement, will always be executed because it doesn't depend on that condition. So there's times when an if statement is followed immediately by another if statement. That is what we call nesting or nested if statements. When you read your notes, you can read there. So in this case, we have our first if statement, which checks if the weather is good. If that condition is met, if that condition is true, then we are allowed to go into the next if statement and check, did we find a nice restaurant? If we did, then we can have lunch in that restaurant. Are you following now? For now? Okay. But what happens when the weather is good, but we did not find a nice restaurant? Then we just eat a sandwich at home. And again, but what happens if the weather is not good? If the weather is not good, then we cannot go inside the next if statement, because this one depends on the first one. Can you see that? So if the weather is not good, then we're going to jump to this corresponding else. Then we check if tickets are available. If they are available, then we can go to the theater. But if tickets are not available, you can go shopping. Do you all understand how this works? Then if you have subsequent if and else statements, if you look from here, this is what we call a cascade of if and else if statements. So how this will work is we have different statements and conditions that do not depend on each other. If you saw from the previous example, our first if was dependent on the if just below it. But in this one, say if the weather is good, then we go for a walk. And else, if the tickets are available, then we can go to a theater. Else, if tickets are available, we go for lunch. So in this case, you can say it's somehow a priority that you can do for yourself. The first thing you would like to do is, if the weather is good, you can go for a walk. But if the weather is not good and you check if tickets are available, then you can go to a theater. But if tickets are not available, you can check if a table is available in a restaurant. Then you can go for lunch. But if all these conditions are false, then you can play chess at home. Did you get that? And then we can look at more types. Again, the open book quiz is there from last week Wednesday. I remember when we were talking about integers, int, and what you need to know about int, most of the time integers are stored as 32 bits, which is 4 bytes. Do you know what 32 bits is? You know that. And that the range of a 32 bit should be that number. If you say 2 to the exponent 32, 2 to the power 32. It's that number. I think it's more than 2 billion. It is a range of 2 billion. So if you want to count, if you want to write a program that counts the number of people that are in this class right now, do you think it is wise to use a range of that much, 2 billion? That would be a waste of memory, right? But if you want to count the number of people in the world, then we will need something more than 2 billion. There's 7.6 billion people in the world. So we'll need something more than 2 billion, a range that is more than 2 billion. Yeah, I think 64-bit. And if we want to represent a state of maybe these lights, whether they are on or off, then we only need a 0 and a 1. A 0 to represent off and a 1 to represent on. And sometimes if you look at the range for an int, it starts from -2 billion to +2 billion. But sometimes you don't need that negative part, like the example we made, counting the number of people in this room. There will never be, that number will never be a negative, is that right? So we don't need that part. So that can also be, so we can see how all these scenarios can be accommodated in programming. So to make that accommodation, we can use what we call modifiers. So there's these 3 modifiers that we can use. The first one here is long. If you want a wider range, we can use the modifier long, like the example we made of counting number of people in the world. And along is along is 64 bit, which is 2 to the exponent 64. That is a huge number. And if we want to count the number of people in this room, we need a shorter range. Then we can use a short. And if whatever we are counting doesn't need or will never be a negative, then we can use the unsigned modifier. Sure. Yes. Yes. So this is an example how we can declare a short. Can you see it says short int counter? So this counter is a shorter range. But we can also declare it like this. We can leave out the int, because by default, if you leave out that type, then by default the compiler assumes that that variable is an integer. And here they used an example of counting the number of ends. I would say they used a long, because a long is 64 bits. That can accommodate a wider range. Do you see how big that number is? And we used unsigned when we want to, like the example we made, the number of people in this room. We agreed that the number of people in this room can never be a negative. Is that right? So we used unsigned. Like we said, you can use the type int, but if you decide not to use that type int, it's still okay. It's still correct, because it is assumed that that variable is an integer. Like you asked, you said, can unsigned be used with long and int? Yes, it can. Like, I mean, with long and short. And here there's an example of how they used declared huge number, but it's an unsigned long. Can you see? And we can also use it in short, unsigned short. That's the number of lamps. Do you remember when we talked about HR characters? We said HR is, how big did you say HR is? It's 8 bits, which is 1 byte. It has a range of -128, from range of -128 to 127. But if we use it for something that doesn't need the negative part, it can have a range from 0 to 255, because we just shift it from the negative part, we shift it from the negative 128 to the positive part, which will start from 0 to 255. You see, we still don't lose the range. It can still accommodate the same number of variables. But we cannot use char with long and short, but we can use the unsigned modifier. Do you remember literals? The literal L can be used to declare a variable that is a long. If you look from here, like this letter L, if I want to declare this 0 as a long, I can put the L right after the 0. So and it doesn't matter if it's a capital letter or small letter. It will still be identified as a long. It's a literal of type long. And we can also not use the modifiers long and short with floats, but instead, if you want a wider range for floats, we use what is called a double. So it's a double because it has double the range of floats. And the difference between a float and a double is that a double has wider range and it is more accurate than a float. If you look here, they say floating point variables has finite precision. It means its precision will come to an end. You know, finite. So in here we have an example of a long with 1111 dot. And if you store this float in a computer as a float, it can be stored as that value. Do you see now that this value somehow has changed? That is why they say floats are double are more accurate, because now if that's our new value, then it's not accurate to that what we wanted to store. And it's also, and its range is also less than what you wanted to store. Are we still good? And floating points only save the first 8 digits. If you look our value and what has been stored, only the first 8 are correct. Can you see that? Do you remember bool? What a bool is? True or false? Well, I think we made an example earlier of if you want to store the state of the lights. Do you agree with me that we can use a Boolean expression to store the state of this light? It's whether it's true or false. It's on or off. And off is for 0, and on is represented by a 1. There's a short history of how that word bool comes from. You can read that. There's an example here. If a developer is hungry, then he will have lunch, and the hungry developer then becomes not hungry. Once you eat, you become full, which is not hungry. So hungry can be false, and full can be true when we use a Boolean expression. And they repeat here, true is equivalent to 1, while false is equivalent to 0.